Now let's put our solubility rules to work through what we call precipitation reactions. What does that mean? So a precipitate is formed when an insoluble compound is produced as a product of a reaction. So you have two soluble substances, and then they're going to make products, but one of the products is not soluble, so it looks like it snows. So it looks like it snows inside the container. So think precipitation, rain and snow. You see it look like it's raining in the container. So here, if you have, the way that I like to work these is here's your reactants. Now these are soluble, so they break apart in water. So K2CrO4 plus BaNO3 2. All right, I like to do these, and now these will indicate that they're aqueous. That means it's dissolved in solution. So now let's just do a double replacement. So potassium goes with nitrate and barium goes with chromate. Okay, now it's balanced. Now let's look at our solubility rules and see if things are soluble. Potassium is always soluble, so we'll put that as an aqueous. Barium chromate, look up on your solubility rules up here, anything there that says it's soluble? No. So if it's not soluble, it's going to show up as a solid in solution. So this would be your precipitate. So let's look at this one now. See here, way the book tells you is break them all apart and look and see if any of them don't go together. Again, I like to just switch them around as a double replacement reaction and then look at the solubility rules. So you can do it like that if you want. This is important when we're going to talk about how to represent them, but determining if there's a precipitate, just switch them around. PbSO4 plus NaNO3. Two of them. All right. Now, lead sulfate. Sulfates are soluble except when with lead 2. Guess what? That's a solid. Sodiums and nitrates are always soluble, so that's super soluble. So this would be your precipitate. How about this one? Just switch them around. KNO3. Because again, you may have to write your charges to get these. And nitrates and potassiums, those are always soluble. There's 2 of them to balance the equation. Sulfates are not soluble when they're dissolved with lead. That's your precipitate. Okay. Sodium chloride, silver nitrate. Silver goes with chloride. Sodium goes with nitrate. Nitrates and sodiums are always soluble. AQ. Silver and chloride. Oh, chlorides are soluble unless with silver. So there's your precipitate there. All right, switch these around. -1 + 1 + 2 - 1. Okay. So here we're gonna have CaCl2 and ammonium nitrate. So we need 2 of those and 2 of those. All right, calcium chloride, is it soluble? Chlorides are soluble with not any of these exceptions, so that's soluble. So this is aqueous. Ammonium and nitrates are always soluble. So here, are we going to see anything in solution? Is anything going to come out? Everything's going to stay in solution. So we're not going to visibly see anything. So even though this is happening, they're still soluble, so they're still technically breaking apart. So we would indicate this as no reaction because we're not going to see anything come out of solution. All right, so let's look at this. -1 + 2 + 1 minus 1. Okay, so PbCl2 and KNO3. And we need 2 of those. All right. Lead 2 chloride. Lead 2 is almost always insoluble. And nitrates are always soluble. So yes, there's our reaction that we'll see come out. All right. Here we're given a word equation and we need to make it into a chemical equation. Aqueous nickel 2 nitrate added to aqueous potassium carbonate to form solid nickel 2 carbonate and aqueous potassium nitrate. Okay, so nickel 2 nitrate. So that's nickel plus 2, nitrate, NO3 minus 1. We don't charge balance. We need 2 of them. So this tells us it's aqueous, so let's put an AQ. It's dissolved in solution. Added to aqueous potassium carbonate, and it's aqueous, to form solid nickel 2 carbonate, so NiCO3 minus 2, it's solid, plus aqueous potassium nitrate, KNO3, aqueous. Now let's balance it. Nickel, carbonate, 2 potassiums, 2. There we go.